Thousands of people see this complex every day, often without realizing its significance. In fact, it is one of the most important industrial centers in Australia. The materials produced here find their way into products which are familiar in everyone's daily life. Indeed, it would be hard to imagine going through a single day without coming in contact in some way with one or more products which originated here at the Altona complex. The complex is situated 12 kilometres almost due west of the city, between the Princes Highway and the Geelong-Melbourne railway line. It is surrounded by other heavy industry and vacant land. The Altona residential area lies to the southeast. The complex had its beginnings in May 1961, when the B.F. Goodrich plant was officially opened by the then Premier of Victoria, Sir Henry Bolte. By the end of that year, 4 more companies had commenced operations on the site, and by 1967, the full complement of companies was in production. The complex today is a grouping of 7 independent companies. Some of the companies buy raw materials from one another. They also work together on environment control projects. The individual companies on the large triangular site are Altona Petrochemical Company, Commercial Polymers, Australian Synthetic Rubber, BASF Australia, Dow Chemical Australia, B.F. Goodrich Chemical, and Hoechst Australia. Raw materials are moved to and within the complex largely by means of pipelines. Much of the basic raw materials consist of ethane from the Bass Strait oil and gas fields and gas oil feedstock from the nearby petroleum refineries Australia. These are processed by Altona Petrochemical Company to produce the petrochemical raw materials, which are in turn used by other companies in the complex to make their end products. The companies also use raw materials from other parts of Australia. The end products tend to have long, complicated names like these. In simple terms, they are materials used by the plastics, chemical and rubber industries in the manufacture of a vast range of products. Here are some examples. Commercial polymers products are used in the making of such things as polyethylene film used in food wraps and shopping bags, bottles, water and gas pipes, wire and cable insulating materials, and a variety of molded products and pipe. The output of the Hoechst plant is used to produce automotive parts, bottles and other plastic consumer goods, paint, printing inks, adhesives and agricultural chemicals. The products from Australian Synthetic Rubber go into motor tyres, conveyor belts and a range of rubber products. This company is Australia's only synthetic rubber plant. Dow Chemical makes a variety of materials destined to reach the final user as packaging, paints, carpet backings, insulation foams, foams for furniture and structures such as boats and swimming pools. B.F. Goodrich's product appears to the consumer as mouldings, pipes and fittings, flooring, cable insulation, wallpaper and upholstery material. And BASF at Altona puts out a range of raw materials to manufacturers involved with insulation, packaging, paper coatings, textile printings and leather, paint and adhesive products. Together, the 7 companies make up the biggest petrochemical production centre in Australia. Their total investment in plant and technology is huge. Over $500 million has been spent so far. The replacement value of the plants would be well over $1 billion. The technology involved is very advanced, right up with the best in the world. Most processes are 24-hour, highly automated, enclosed systems. The complex makes a substantial contribution to Australia, Victoria and its local community. Economically, the figures indicate its importance. The complex produces goods worth around $600 million a year. To produce these goods, the companies purchase raw materials and services. When all of this is taken into account, its contribution to the Victorian economy is close to $1,000 million, or 5% of the state's total manufacturing industry output. It is responsible for about $90 million of household income, about 2% of the state total. In employment terms, its impact is equally significant. Indeed, it is the area's largest employer. Over 1,900 people are employed here, covering a wide variety of trades and skills. Again, taking into account other workers whose jobs depend directly on the activities of the complex, the total is about 4,000, or 1% of the state's manufacturing industry labour force. Its value to the local area, Altona and nearby suburbs, is enormous. 13%, about 1 in 8 of the local workforce, is employed at the complex. Financially, the companies are responsible for 20% of Altona's total rate income. The benefits of these rates, plus other expenditure in the area, amounting to many millions of dollars per year, can be seen in such things as the development of Cherry Lake as an outstanding local recreation facility. Indeed, many of the recent improvements in Altona as a place to live can be attributed directly to the injection of money into the area by the complex companies. But the responsibilities of the companies do not end with spending money. The complex is very conscious of the need for industry to protect its neighbours and the environment. By its very nature, the petrochemical industry involves the handling and storage of potentially hazardous materials, some flammable or explosive, others toxic. So every effort is made to ensure the safety and well-being not only of the people who live in the area, but of those whose working lives are spent in the complex. As a group and individually, the complex companies follow a comprehensive, well-established program of environment and hazard control. In total, over $20 million worth of sophisticated monitoring and control equipment is in use, and around $3 million is spent every year on environment control systems. A total of 22 people specializing in environment control is employed full-time in operating the systems. Coordinating the environmental activities of the Altona complex is CESC, the Complex Environmental Steering Committee. This committee meets regularly to review the environmental performance of the complex. It also provides a means of sharing the latest expertise and technology from all over the world. Task groups study the individual areas of water discharge, air quality, waste disposal, and noise level. Regular testing is carried out of the purity of the complex's wastewater, which, after treatment, joins the Cororoit Creek. Air quality monitoring is especially important. Industrial solid wastes are disposed of under strict supervision at the site especially chosen for the purpose at Tullamarine. Noise levels are measured to determine the effectiveness of noise reduction programs in the complex. Another important aspect of the committee's work is keeping in touch with the public. Any complaint received is thoroughly investigated to determine whether the complex may be responsible, and if necessary, steps are taken to minimize any problems which could interfere with quality of life. Over the years, the number of complaints received from the public has steadily declined. For example, over the 3-year period from 1979 to 1982, complaints fell from 94 to 18, and some of these are known to have originated from sources other than the complex. All emissions by industry must, of course, be licensed by the Victorian Government's Environment Protection Authority, and the complex works closely with the authority to ensure that its standards are met. It is recognized that the Altona complex has a good record in environment control. Equally strong is its record in safety. Each plant has its own safety program and emergency procedures. Hazard control is based on high engineering standards, strict adherence to correct maintenance and operating procedures, regular inspection of plants both by the company itself and by government authorities, and training programs to maintain the skills and safety awareness of personnel. There are prepared plans to deal with possible contingencies. An emergency may be classified as either an in-plant emergency, which would be controlled within a plant using its own manpower and equipment, or a mutual aid emergency for which the assistance of other complex companies would be called for, or a complex emergency affecting more than one plant and requiring the assistance of outside services such as fire brigades. To provide for rapid cooperation between plants in the event of a serious emergency, the companies in 1962 formed the Altona Complex Mutual Aid Group, known as ACMAG. This also includes the nearby plant of Petroleum Refineries Australia. The group has developed the Altona Complex Emergency Plan. A UHF radio network has been set up between the companies to speed communication. Most equipment is standardized to be compatible between plants. This is an ongoing program. Exercises are held frequently, with crews being trained in firefighting and emergency techniques. The chemical industry has a safety record many times better than the average for all other industries, and the complex is determined to maintain that record. In addition to their collective approach, each of the companies carries out its own programs of environment control, safety, and occupational health. At BF Goodrich, solar-powered air monitoring devices are placed at several points around the plant boundary. Air is automatically pumped through a tube packed with activated carbon. These tubes are taken at regular intervals to the laboratory for analysis. Air quality within the plant is also constantly monitored by automatic analyzers. There is also a continuous program for the personal monitoring of employees. Monitoring of plant functions is a vital part of meeting high environmental standards. Close attention to these functions also contributes to BF Goodrich's energy conservation program launched worldwide in 1973. Safety is given a high priority. Training sessions are held each week. The company has received recognition of its efforts, such as an award from the National Safety Council of Australia for 1 million man-hours free of lost time injury, representing over 2 years of plant operation. Wastewater treatment is important with all the complex companies. At Commercial Polymers, in addition to operating a very efficient water purification plant, a water conservation program has steadily reduced the plant's water usage. Consumption has been halved, and discharge to Cororoit Creek is now zero. High-quality reclaimed wastewater is recycled within the plant either as cooling water or to irrigate the lawns and gardens. Some of the reclaimed water is being used to develop permanent pasture and trees on land to the west of the works. At Dow Chemical, a laboratory scale model simulates the operation of their wastewater treatment plant. This enables Dow engineers to assess the efficiency of the process. The scale model allows for 3 separate experiments to be run concurrently, and their results compared with the existing method of treatment. In this way, the effects of changes in the wastewater on effluent quality can be assessed before discharge to the environment. In the area of safety, Dow is heavily committed to employee training. A network of TV monitors throughout the site is used to telecast programs on safety and technical processes at various times during the day and night. A well-equipped TV studio enables production of communication and training programs on site. Dow's safety record is outstanding. During the 1970s, their Altona plant operated without a single lost time injury for more than 8 years, representing over 4 million man-hours. This aeration lagoon is part of the extensive water treatment facilities of Hurst, Australia. Treatment of the plant's effluent is based on a biological process in which microorganisms literally eat the waste matter in the water and convert it into solids. Water containing waste materials from the manufacturing processes and from sewage from the canteen, showers and toilets is passed through a series of ponds. Any suspended impurities remaining in the water after the attack on them by microorganisms are allowed to sink to the bottom in settling ponds. After several days in the ponds, the water pumped away to join the outfall from the complex to Cororoit Creek is acceptably clear and clean. Water treatment also receives a high priority at BASF Australia. Because of the nature and relatively small size of their manufacturing process, BASF faced a problem of very high turbidity in their wastewater. Tiny particles of plastic polymers form an emulsion in the water, causing it to appear milky. The water is put through 2 processes to overcome this turbidity. First, a flocculation process partly absorbs the particles, after which the water is put through a biological oxidation process. Continuous development over several years has enabled both treatment processes to now be completely automated. Over at Altona Petrochemical Company, regular attention is given to plant safety and environmental control. The company has an outstanding safety record. It also uses latest technology to overcome any environmental problems. For example, they faced a problem of occasional smoke emissions when, in certain conditions, for safety reasons, excess gas had to be disposed of by burning via a flare stack. Now, the latest overseas technology has helped APC to overcome this problem. This optical sensor, mounted at ground level, monitors the flare tip at the top of the stack. The instant any smoke appears, the sensor, through an electronic control unit, responds by automatically causing the injection of high-pressure steam into the flare. Within seconds, the smoke from the flare is eliminated by more efficient and cleaner burning of the gases. Another occasional environmental problem was solved by the installation in 1981 of this storage tank. About 10 complaints a year were being received about an odor released during the handling of a chemical called mercaptan used in furnace operations. Costing more than $250,000, this storage tank and associated facilities eliminated the venting of gas to the atmosphere. Since its installation, not a single complaint has been received about the smell of mercaptan. In any industrial area, noise can be a problem. The Altona complex companies endeavour to minimize noise. At Australian synthetic rubber, for example, all new equipment has a maximum noise specification, usually 85 decibels, measured at a distance of 1 metre. This approach works towards continually lowering plant noise received in the community. All the complex companies have programs to guard the health of employees. At Commercial Polymers, a well-equipped medical centre is run by a qualified occupational health nurse and a doctor. Advanced medical equipment is used to give regular screening to all employees. A doctor acts as a full-time occupational health advisor visiting all companies in the complex. The concern for the environment, safety and health shown by the Altona complex is not merely a token effort. Its willingness to spend money and allocate manpower to these matters goes back to times before the rise of general community awareness. Before, for instance, the establishment of the Victorian Environment Protection Authority. The complex believes that it can and must exist in harmony with the community, while at the same time continuing to fulfill its role as one of the most important industrial centres in Australia, contributing to the national economy and to the standard of living of the people of this country.